Hi, I'm Jim W6LG, your ham radio Elmer here on YouTube. Welcome to my radio room in Rockland, California. And with me is my friend Ben VE6FSF. Let me start over again. Hi, this is Jim
Good.
W6LG, your ham radio Elmer here on YouTube. Welcome to my radio room in Rockland, California. And in Calgary, Alberta is Ben VE6SFX. That shouldn't be hard for me to say. Now, SFX, I say that because my father was involved in special effects
Right.
on some famous TV shows like Star Trek, but on the
Yeah.
budget side. Now, is your call sign related to special effects or anything to do with that?
It is actually. I my sort of last career of many was doing special effects for movies. In fact, the first movie I worked on was Star Trek Beyond. So,
No kidding.
yep.
Oh, wow.
Yeah.
Um, Then several months ago, I purchased from you
Hmm.
this,
Yeah.
which is kind of neat because it's a piece of cloth, fabric, material of some kind or other. And what is neat about it, and this will surprise folks, is this end of this cloth has a BNC to UHF female or SO239.
Yeah.
And it's an antenna. And I needed
You
it for
bet.
the project. And it's fair to call it a J pole.
It is. Yeah.
Yep. And the other end has a little gizmo for hanging it. So I was able to hang it down. In fact, I used it in here. This
Hmm.
was so much night and day difference between this and we'll call it a rubber ducky, even though I don't like that much. But it, it was so much better. It even had my call letters on it. It was like 9 days. Couldn't hear anything with that because I'm in a
Yeah.
room that's pretty well isolated. Put this up and it was full quieting to the repeater. What
I
is
get that.
this? What did you?
It's Faraday fabric.
I need you to I need you to explain yourself.
So there's another video that we did, and we chatted about some of this, but the what it boils down to is that it's Faraday cloth. Normally, Faraday cloth is used for blocking frequencies or blocking radio waves,
Mhm.
and I
As
started
as in
seeing there was a
Faraday
lot.
shield, like a Faraday shield.
That's right.
Okay.
Yeah. And it's just it's a fabric with it's polyester with a nickel and copper coating on it.
In here?
Yeah, it's a vapor deposition metal that's on the shiny fabric, and so there is some metal in it. It's just kind of disguised as fabric. It kind of feels nice. Um, is the one thing I noticed though when I was starting to get into ham is that people are starting to play with these magic carpets and using the Faraday cloth as the ground plane. And it occurred to me that, well, wait a minute, it's meant to block RF, but that doesn't mean that it can't transmit RF. So if you can get strips of it, would it work as, wire in an element? And my first tests, I've got my YouTube channel and I did my first test and you can see me jumping on my back porch because I got way overexcited. It was one of those things where it seemed to be too good to be true. I couldn't really believe it. And I actually was kind of nervous about putting the video out there because I'm thinking, am I missing something? Am I just transmitting on, the coax or something like that? And so that was like about 2.5 years ago. So 2.5 years later, I can confirm after 5,000 plus of these antennas have been sold that,
Oh, of this
no,
one?
yeah,
Hey, really?
yeah, yeah.
Congratulations. That's a lot.
It is. It went from me thinking I was going to have like a little side gig to, maybe get some beer money or coffee money
Yeah.
to full-time job within I tell people months, but the reality is it would took about a week. When I first started making some, I made 100. They sold out in a few minutes. The next set, I made 250. They sold out in less than half an hour. The next set, I made 500. They sold out in less than an
Okay.
hour.
somebody watching this video may want to buy one. So what I'm going to do, because we hadn't, this is not what we plan to do, but what I
Mhm.
would like to do and will do is I'll put in the description a link to your website where they can purchase this.
Yeah, I'd very much appreciate that. Not
Oh, that's
expected,
okay.
but I'd appreciate it for sure.
Yeah. And about how much is one of these things?
Those are 75 US, not including import tariffs and everything
Yeah.
else and all those other taxes and everything that
Other,
governments love to throw at people.
yeah.
So, yeah.
Now, what in the world were you thinking about? Um,
I,
yeah, somebody asked me about you, who was a mutual friend, and that was
mhm.
Vince.
Yeah.
And I said, you, now I grew up in Hollywood around some folks who are pretty creative. So, and you worked there, and you would look at something different than I would. I would
Yeah,
look at a table and I'd say, okay, six people can sit here. You might look at a table and go, oh, I could turn that into an antenna.
yeah. Don't tell my wife that, but yes.
Yeah, and I believe that. Now,
Yeah.
in my family, because I've already asked you this question,
Mhm.
in my family, there were folks who were right-handed and folks who were left-handed, and I was
Yeah.
right-handed. I was good at math as my father was, and my degrees are
Mhm.
in finance, but I have no artistic ability at all. My grandmother, who was left-handed, and my brother, who is left-handed,
Mhm.
was very artistic, or is very artistic. You're left-handed, you're very
Yes.
artistic, and also um, you look at things different than I do, which is my example of the table. I look at
Right.
it as a table. You look at it, what can I make that into? What
Yeah.
can I make it do?
It, and
You're
I
gonna,
it's one of those things I can't explain. It's just kind of like how I'm wired. Maybe you're right with the left-handed thing. Maybe it's just one of those things where
yeah,
it's
the
genetically.
your brain works on the opposite side.
Yeah.
That's probably an advantage, but it, but you have really come up with some things that are different, like this,
Yeah.
which is a J pole, which is a very simple antenna and a very effective antenna. Really,
Very much so. Yeah.
yeah. Um, what else have you looked at doing? What's next in the scheme of things that
Well,
Ben SFX has come up with?
well, the first thing is that I've done a video on like I did a random wire, but I call it a random stick. So you take the squid poles or the long fishing poles that you can get fairly inexpensively that are carbon. And before somebody, I don't want to go down the carbon rabbit hole, but carbon doesn't affect antennas nearly as much as people think. Yes, it does affect them, but not to the extent that it should stop you from using it. Like we're talking like fractions of a percent. So in that thought process is that if you've got a material that works really well, why not use it and sacrifice that fraction of a percent and be able to work with something that is tougher and stronger? But if you take the Faraday fabric like this here and you stick it to the side of this, now instead of putting a squid pole up into the air and then running a wire up and down it, and I hate messing around with wires, I end up getting tangled up in them and they anger me. I figured why not attach the wire directly to the
Okay.
pole. So now the pole you can extend out, the radiate element is on it, and it works really well on 20 meters. And I'm just finishing off sort of like a product where we've got like a tripod.
Oh yeah.
Um, that, yeah. And then you just put
Do
the
those
antenna
extend?
up.
Do those pull out further? Are they telescope?
They do. Yeah, you can pull this and
By the
it
way,
does ex
there's some noise being generated in the audio, so if it comes through on the recording, I apologize, but I don't know how to stop it. So those
yeah, no worries.
telescope out to give you a bigger footprint.
Right. But if that doesn't work, there's also like a 3/8 thread on the bottom. So you can
Oh,
spike
cool.
this into the ground if you need to.
Yeah, which is not all uncommon. So
Right.
now this so the conductive materials on the outside of that, and that
That's right.
slider makes contact with that.
Yeah. Here's where it's different is where people normally would be taking like a, here, I'm just going to put that down. They'll take like a feed point that's at the base of the antenna on a spike and then put
Mhm.
the antenna on top of it.
Right.
And that works fine. You know, you can get the ground plane and everything on the bottom part, but it doesn't allow you to adjust things. And with a stainless steel whip, you can put them up in the air, but they are fragile in the sense that like once they're folded, they're screwed. But at the same time, when you slide it up and down, if I move it 6 inches down, it'll stay at 6 inches down. But with these, they're sort of locked in on segments that are about this long, and they have to be fully extended and locked in. So when you do that, then you're kind of at the mercy of the length of the pole. So
Okay.
what I ended up doing was is since we have the Faraday fabric here and there's a Faraday tape that comes from the center pin here, and you can do fine adjustments by sliding the
Oh,
feed point up and down.
so that's how you make contact with the center conductor on that
Yeah.
SO239 is with a Faraday
Yeah,
material.
that's right. And then I've just got like a little adapter in the bottom here. This is a 3D print that'll come with the product when it comes out is there'll be a BNC. So you clip that in with a wire, and then whether you clip this to Faraday fabric or counterpoise wires or,
Uh,
a fence that happens to be nearby or whatever. But like, at that point, you've got your ground plane can be established
okay,
quickly that
so
way.
that's basically a quarter wave element.
Yep.
I think of everything as a dipole to start with. So
Yeah.
what that is the one end of the dipole is vertical, but there's an advantage to that, and I'm sure you've already figured that out. You don't have the losses of a coil, and uh, I mentioned that for a reason. A lot of antennas, without naming anything in particular,
Hmm.
have a coil right
Yep.
at the feed point, and that's not necessarily a good thing. I understand the advantages of it
Yep.
because it's easy to match. But the high current placed on an
Yeah.
antenna is at the bottom. The high voltage is at the top. And so you don't want to mess with the part where the high current is because that's what does the radiating. So
True. And here's one thing a lot of people don't take into account. And if you have a stronger pole to put your antenna up on, is put that coil like 3/4 of the way up or at the very top. And you're going to find that because it's at the voltage end, you'd end up not having as much loss and the current is not there. So it actually works a lot more effective. So the
and
further up you can get a coil, the better. If you can get rid of the coil entirely, that's awesome. But
as I
yeah,
said, I think of most antennas to start with as a dipole. And if
yeah,
you think of the dipole on a driven element on a tribander, where are the traps? They're
yeah,
right at the end.
yeah.
uh, for a couple of reasons, but there's also a lot less loss because they're out here. In fact, you could whack off the end from the trap and just cut it off,
Mhm.
and there wouldn't be that much loss in the element.
Yeah.
However, I'm a big believer in not losing a dB here, a dB there, dB over here, because after a while you're down 3 dB,
Mhm.
which is not good. So that's going to be a very efficient antenna. Um,
I I hope so.
yeah. Now,
It works for me, but again, this is me. Vince has played with one just recently. I've had actually Salty Walt, another
okay, yeah,
YouTuber,
yeah.
has played with one. And I think those are like the people who have actually used this antenna. And I've gotten some good feedback, but all of it seems to be like everything that this is one of those things where you can make something and put it out there, but you're gonna like in your own mind, you're gonna justify or try to make things work better in your own head. So I always like getting it out to other people that are experts and going like, be honest with me, be brutal, tell me what works, what doesn't, because I'm not going to learn and I can't make the product any better. And, there was a few things, lessons learned on another product that Vince and I learned last weekend, actually, which was kind of neat. And I'll bring that one up here in a bit.
Yeah, and so Vince used that. What do you call it? That tripod that we just looked at?
That one I've yet to come up with a name, but I'm thinking I want to call it the random stick, even though it really isn't necessarily a random wire antenna. It just there's something about the name that just makes me giggle.
Yeah, I'm not sure that random works. No offense,
No,
because
no.
random, I think of a random wire antenna. And
Yep,
that's anything but random, uh, because as I understand it, it's going to be like a quarter wavelength tall.
that's
Now,
right.
on 20 meters, how tall will it be? It'll be a little
It's
bit.
just slightly shorter. So these ones are about 15 and a half feet instead of 16 feet because the velocity factor and the way the Faraday fabric works, it ends up allowing us to make the antenna a little shorter. Plus, when I put the Faraday fabric on the outside or the Faraday tape on the outside, I'm also painting over top um, a urethane finish just to finish it off and to bind the Faraday tape to the carbon fiber. And when you do that, like adding any plastic or any insulation obviously is going to change it. And if anybody's played with like standard J poles or used a feed line to make J poles, the second that you stick it into like say a PVC pipe to keep it protected from the
Mhm.
elements, you find out immediately that you need to shorten everything up a little bit.
Yeah,
So, you know, combination of everything that kind of
I
makes
found
it.
that out when I used PVC pipe and I put light bulb Christmas lights on it,
Yeah.
and I drove it like a dipole, and the
Oh,
results
awesome.
were, uh-oh, yeah. Um, and in fact, I'll tell you another story. I took PVC pipe, turned it over to the machinist, and I had him groove it, and we put
Mhm.
a coil on it, and I transmitted into it, and it bent over like a piece of spaghetti. I just heated it up and went over it went. Um,
Little too much power, baby.
Me?
Well,
Um,
if you I
well, I had
refuse to comment on
to
grounds that it might incriminate me.
I had to see where it would fail.
Yep. Oh, I get it.
And it did.
Yeah.
It turned to liquid plastic.
Yeah.
Yeah. Oh,
Well,
that
and
and another
this
one I
isn't
had. I and this goes to the point of the high voltage. I had an antenna, had a coil, a vertical rod, and then a capacity hat.
yeah.
And I put the capacity hat together because I was selling these things. And
Hmm.
I had the rods, but I didn't put on the little tips on the rods.
Okay.
So I go into the house, this thing's mounted on the back deck, and my wife is outside. She's doing something. It's nighttime. I did it
Yeah.
at night so I could video this thing. And I transmitted into it, and I heard her screaming. And I went out there, and each of the rods for the capacity hat was putting out an arc about this long. Uh,
Oh, awesome.
yeah, it was cool. Going zzz.
What I'm wondering if that classifies as St. Elmo's fire at that point. St. Elmo's
Uh,
antenna.
it was my wife's fire. I'll tell you that. Like, what are you doing? Um, it's
Yeah.
not the first time I've started a fire, by the way.
Yeah.
Um,
But that also goes to something where I know that you had mentioned that like, you know, you try to save every dB. And I do too, but like, you know, when you're using carbon, you might lose a little bit. And you're not losing the dB. You're losing just fractions of. But this would be an example where had you used a carbon fiber rod and you jammed that much power through it, it wouldn't have folded over. So it's one of those where the material kind of trumps the situation in this
yeah,
case.
many antennas have some loss.
Oh yeah.
Yeah, the point is to mitigate those losses as best. That's a big word. As best you can. So I try very hard. Like if I have a choice in coax going out to an antenna, I will use LMR 400 or LMR
Mhm.
600. In fact, I've got 7/8 inch hardline out to the
Right.
tower, um, mostly because I had it, but it's almost lost less, and
Yeah.
it's been great fun to have it.
No, for sure.
Okay, so are you working on anything else now, or is that kind of where you're
No,
at?
that's not it. And much too like so I going to the business side of things, things got busy enough that I have a part-time assistant that I've hired. And Her main job is to be my boss and to keep me on track. And I drive her insane sometimes because, like, we've
Well,
been working
that's
on,
a surprise, Ben. That's
yeah, shiny. It's like, woo, you're gone. Um, so I've come across another Faraday tape-like material. I'm going to leave it at that because this is just in its genesis, and I'm not sure exactly how I'm going to release it. But um, it comes in this roving, and it's really fluffy and kind of a pain in the butt to use. And it occurred to me that you can do what's called with wiring harnesses, you can do overbraiding. And effectively, what that is if you know uh, parachute cord or paracord, the outer sleeve
yeah,
is
I
an
do
overbraid.
actually. Yeah,
Yeah. So you can also get that
it's a
stuff.
little bit like a coax because there's an outer
Yeah.
woven material and then the sometimes white
The
inner,
core materials.
yeah,
Yeah.
core material. Okay.
So I've changed the core material out for this magic stuff that I have, and I've made this like 16th inch cord, which is this isn't paracord. It's it's well, it is like a paracord, but it's called Type 1 paracord, so it's 1.2 millimeter or like 16th of an inch. And because I was impatient and couldn't get this stuff to an overbraider, I just ended up doing some rigging. So another previous life, a long time ago, I know a lot about ropes and tying knots and all this stuff. And you can recore a rope if you do it properly with things called FIDs. So I pulled it through
Wait a
this cord.
second. What is it? What if you're holding up a piece of
Th
rope or no?
no, okay, so this is a radiating element. You can treat this just like
Wait a
a
minute.
piece
That's
of
a piece of
wire.
black rope.
Right. But but it's also very conductive rope. And it's got a fairly decent resistance, like regular standard resistance
Uh-huh.
of 1.6 ohms per meter. And a lot of people are going to go, oh, but
Well,
if you're doing something, say under 100 watts, this actually works out really well. And there's things that you can do, like you can tie knots in it like that, and
I
it
see.
doesn't affect anything. And I dare you to find a wire that you can tie a knot into. The other neat thing is another advantage of the material, the core material that I have, is it's very strong. This cord has a breaking strength of 300 pounds.
What?
Just one line, this is 300 pounds,
I
this would be
sold
600.
in one of my lives, I sold rope,
Yeah,
and there's no way in heck that the stuff I had would hold 300 pounds.
right.
Um,
So the advantages to this, and I've been kind of like, I made it because I got really excited about it, and in some ways I feel like it might be a solution looking for a problem, but I know it isn't. I'm just trying to figure out how to properly tell people about the stuff because
okay, look,
like
so what you're holding, so I'm clear.
yeah,
So I'm on drugs. Um, that rope you're holding is conductive, and it's
yes,
almost as conductive as copper wire.
right,
It'll handle 100 watts anyway.
yeah.
So if I wanted to make a dipole out of it, could I do that?
Oh yeah, we've already done that. Vince and I last weekend well, we never made a dipole. We just did a quarter wave line just straight up along one of our squid poles, and yeah, it worked fine. It radiated out just perfectly. But here's one thing that we discovered, and well, we have discovered half knot. So you can tie knots in this, and you can make it like sliding. And
Yeah.
what you see here is a loop. So I've
Oh,
done
wait a
like
minute.
just
If it slides through the knot, does that change the length of it?
exactly. So the thing is you can tune it by just doing a fold over and pulling it through and then locking it in on that. Here's where it doesn't work is that I'm going to have to figure out how to put um, maybe little knots or sort of like stop gaps because when the two cords are fairly close to each other, it works as a fold over and it works quite well as a radiating element. But if it's in the wind and those cords start flopping around and getting a space like this, then that fold over is no longer doing fold over things. It's more doing capacity hat things. And it
Uh-huh.
ends up having your SWR ends up bouncing around and it doesn't seem to work fairly
Okay.
well. So,
So
but yeah,
it sorry to interrupt you, but it occurred to me that it's uh, portable POTA perfect. A little alliteration.
I love that.
Uh, because it
The Poda
is.
Perfect line.
Yeah.
I
So
so
you can quote
I've
me
got
on
it.
that.
Yeah, I've got a different name for it. The Poda
Yeah,
Perfect I like.
what name did you call it?
So, 2 months ago, I come from a large family, and I was the last of a large family. I was the last of seven kids. So my oldest brother, had children just 3 years after I was born. Um, so my nephew and he was a twin with his sister, were born just 3 years after me. And when we grew up more like brothers and
Brother and
sisters than we
sister.
did,
Yeah. Yeah.
yeah. He passed away
Oh,
about 3 months ago, and
sorry to hear that.
left the family behind and stuff. And his initials are RSE, so I'm going to call it RSE line. But it's just rugged signal element line is what I'm going to be telling people, sort of like on a corporate side of things. But the back end story of it is that I want to pay homage to him, and
And that's
yeah.
very kind. And there's nothing like that out there, right? This is,
I, this is where I've done so much research trying to find out if there is anything like this, and there isn't. As far as I know, as soon as I'm getting some prototype stuff made, hopefully I think somewhere 800 meters to about 1,000 meters done fairly soon. Gonna send it out to some people to test, maybe send it out to you. But Jim, remember I said 100 watts. This stuff will like poof.
well, that's
But
all I can run from here, you know
yeah.
that.
But here's one neat thing about it too is that we haven't talked about is that with this plastic piece here, this is a 20 meter it's a quarter
Oh, yeah,
wave, so
yeah.
it's only a
Okay.
single piece. But the plastic itself weighs just as much as the rope. This
It
whole
that
thing is
so that's a good demonstration. In other words, the rope doesn't, I don't even want to call it a rope really, but it doesn't
yeah.
weigh anything then.
No, this is zero point 0.8 ounces for a quarter wave 20 meter element.
Wow.
And
Uh,
if you get rid of the plastic, it's probably about zero point 0.4
I
ounces.
mentioned to Vince, I seldom use the word, try not to use the word unique.
Yeah.
And that is unique. I don't think there's anything else like it. Uh,
I, I haven't found it. I'm not saying that it doesn't exist out there, and hopefully I'm not reinventing the wheel, but we'll soon find out. But I think it meets it allows a few things, is that you can tie knots in it, so suddenly having to deal with bites or hardware crimps, if
yeah.
you know how to tie a knot, you should be able to work with this
So it
stuff.
is POTA perfect.
Yeah. Oh, and other neat thing about it too is because of the core material and what it is this blew me away. The other day I was melting the end of it, like how you melt the end of
Yeah.
a paracord just
Right.
to
To
clean
keep
it
this.
up.
Yeah.
But the core didn't melt. It started to glow. And I was like, "Wait, what?" And
Oh, okay.
which made me go, okay, this is odd. So it's obviously not going to melt. It will take the heat. So I figured, well, what happens if I try to solder to it? And you can solder to this stuff. It kind of blew me away. I've been crimping onto it.
It's rope you can solder to.
Yeah.
I don't even want to
Or
call it rope because it's you know what? It's the expression wire rope. It
yeah,
really is,
to a certain extent.
or
And
antenna rope. I like antenna rope, I think. Um,
the other thing too that I found is kind of neat too is if you look at this from a perspective of master rigger or being a rock climber or people at parachute or sail people, is they know how to splice ropes. And when you start doing the splice, you end up having to take the core material and sort of feed it back in through the sleeve itself or
yeah,
the overbraid. When you do that, you actually make electrical contacts.
yeah,
So when you do that, when you do foldovers and stuff, you actually are creating nice clean circuits by getting rid of any of those sort of ugly terminating ends. When you splice it, it actually cleans everything off. But that also brought up one thing with this guy here, and I'm not sure this will actually show very well. Actually, I can just see
yeah.
is that I took some of the conducting element and I fed it in and out and then into the braid. So I have some of the conducting element is on the
Right.
outside. So now I can clamp on, I can clamp onto it with an alligator clip
And what
or
What about those, I'll call them double female crimp connectors where you can stick
Yeah.
a wire in each side? So you could crimp that down and
Yeah.
do about the same thing, right?
Yeah, and if you do things like even you want to splice the rope, as long as so I'm coming up with an idea here while we're talking, is that
No
if
surprise there. Yeah.
if you let's say you wanted to tie two ends together, you have the sleeve on there, it's not going to capacitively couple. At least there will be a little bit of capacitive coupling, but it'll be just that small little area. But if you do a sliding knot on one
Yeah.
arm, like, and then another sliding knot on the other, so you join, imagine this being two cords, not one. This is broken off at this end. If you do something like about a foot, at that point you have a capacitively coupled join, so you wouldn't have to solder or anything. You wouldn't have to crimp it. You could actually just knot a couple pieces together and then do a
So
20 and then make a 40 and then an
So
80.
a guy out in the field, a POTA goes, wait a second, I meant to do this and I didn't do
Yeah.
it. He can just tie a knot in it and get it done that way.
I think so. But actually, you know what? I'm quite confident about that. And the reason I'm quite confident about it is that remember how I was just saying before how Vince and I were testing this, and when we did the fold over, it worked kind of, but as soon as the lines got split apart, it didn't. And that's because they weren't capacitively coupled. But as soon as you get this, and I went back to my shop and I tested it where you bring the lines together close, then they capacitively couple, then it works as the fold over. So yeah, actually that splice will work.
Now, what about if I shoved it into a piece of heat shrink and I
Um,
overlapped it in the heat shrink
yeah,
and
that
then shrunk that's redundant, shrunk the heat sink.
I'm not sure if you can see it, but that's exactly what I did to hook it
Uh,
onto this banana plug here.
You know,
It,
that's an amazing product, and I hope you can manufacture it uh, and get it get it available because I see that. Well, look how big. I had no idea that POTA would be as big as it is.
yeah,
My computer's giving me a message. I've got to get it out of the way. So the POTA is huge.
yeah,
I, I tuned across 20 today, and every couple of kilohertz there was another POTA, this POTA, that POTA to
yeah,
POTA. Um, Guys love it. They're,
yeah.
and manufacturers are making transceivers of one kind or another to take portable. What's missing from some of that is antennas that really work. I mean,
Well,
you and I both know we can make antennas that have a low SWR.
mhm,
They don't radiate worth a darn. Uh,
yeah,
and so there are a lot of things that need to come into place to make an antenna work
yeah.
well. I think that's a hot idea.
Yeah, and that's also my poll idea. Again, that's a POTA soda thing as well.
Yeah. Uh,
Right
that one,
now,
that one has some huge advantages in that if I'm thinking correctly about that slide, and again, thinking about it as a
yeah,
dipole, that's
yeah,
a real fine tuning part of the antenna.
yeah. And the thing is, you got to stick like this, and this weighs, I'm guessing probably about 10 ounces or so, maybe just slightly
Uh-huh.
less than a pound. Um, if you got two of these, so if you're taking 2 pounds with you, you can do things like you can do a delta and you can feed it um, at the base or across like whichever direction you want. Or you can do a dipole and just have two sticking out. Like if you're already on top of a mountain, if you've got like say you're on top of a rock that's fairly high and you can place a couple of weights down, you could do a
Yeah.
dipole.
When I was
Um,
selling antennas, there was a dipole mount that had offset holes for a 3H24 thread, and one side took the coax connector and the element, and the other side was just the element
yeah,
and the pole up through the middle of it. And that worked great. By the way, I did it with just ham sticks when I first
right.
moved here. And ham sticks turned out to be a halfway decent antenna,
Yeah.
but they're not nearly as efficient as what you're showing me, Ben. Ben, I think you've got two hot products there. I wish you the best on those.
Well, I hope so. Do you mind if something just occurred to me while I was messing around here, and I want to ask your thoughts on something here. And excuse me, I gotta clear my throat. My bad. So generally you have these little feed
Yeah,
points,
yeah,
and you've got the negative on the bottom.
yeah.
Um, the biggest issue, this is what I've been seeing, and this is what I've read. So this is like me being the ham radio rookie, is that counterpoise and ground radials are capacitively coupling with the ground, or at least the ground radials are capacitively coupling with the ground. Correct?
In a negative way, they do.
Right. Now, if you take the bottom of one of those feed points and you put a spike through it, does that spike not just short out that capacitor that you're trying to make?
Uh, well, there's an issue there. First of all, dirt does not make a good radiator. So let's just set that out right now.
Okay. Yeah, yeah, yeah.
As a building inspector, I inspected an AM broadcast tower on 830 kilohertz, and they had, I don't know why that's important, but they had radios every 3 degrees. There were 120 of them.
Yep.
Um, they had to bury them because of
Okay.
where it was. People could get access to it, so they buried the radios.
Right.
Um, why did they have so many? Because they buried the radials. If you elevate the radials even 6, 8, 10 inches above the ground, they're fairly efficient. They don't couple so much to the ground. If you drive the stake at the feed point and you go into the ground, it's going to affect the impedance of the antenna. And I think it will lower the impedance a bit. But
Right.
I don't know that it's a great idea. Again,
Right.
because
Because what I ended up doing is that was my thought, and because I was like 3D printing those feed point blocks, is I
mm,
made an isolator. So this top piece is
yeah,
isolated from this, so that
I I think that's a good idea because again, I think of everything as a dipole. So you got one side of the dipole going up and the other side of
yeah.
the dipole going out. Um, guys have said to me, and it just, what are you thinking about? They put up a vertical and they drive a stake into the ground. And they go into the house. You've got the coax connected, and the SWR is low. Well,
Mhm.
yeah, it could be because you've got sort of a dummy load out there.
Yeah.
Get it up in the air. So yes, I think the isolator idea is a good idea to
Yeah.
keep the two separate. Now, somebody may disagree with me, who's an antenna engineer. I'm only basing it on 60 years experience of putting up antennas.
Only.
Yeah.
I'm
Get it
going to
all
base
up.
mine off of future experiments that I'm going to do in my backyard and just try it
Yeah.
with and without and see what the difference is and make that the only change I make. And hopefully it's not me not writing it down and at least getting
Yeah.
some decent data out of it.
I'm coming to the end of the time. In fact, we've gone
Okay.
beyond that, and I'll have to edit out a few things here and there. Um, uh, do you have a rig expert antenna analyzer or something like that?
I do.
Okay, so I think that would be a clue as to what goes on. Would be to is you if you can get close to the feed point, relatively close,
Yeah.
dial in what's going on. I think that's good. That's also another genius product. Those guys are really smart, and
Yeah.
they're very nice too, by the way. Uh,
And the thing is it's a plug and play that you like I've gotten VNAs and stuff and they are awesome, but there's a learning curve to it. With the rig expert, you plug it in, you say, I want to check this antenna, and it does.
it
You
does.
hit a couple of buttons, and
Yep.
there's so much to be said about that.
Yeah,
It's
it's a
absolutely
neat
adored.
neat product, and I do have several VNAs. The reason why I was on Amazon and I thought, oh, I wonder how much VNAs cost, and I come to a listing and
Mhm.
they were 7 or 8, or maybe it was $6 a piece. And yeah, and I went,
Wow.
they had four left now. Okay, so I ordered all four. So I've got a
Yeah.
bunch of them.
Yeah.
One of them didn't work when I got here, but I had nothing to complain about since,
Yeah.
yeah, and I didn't pay anything for them anyway. Ben, I want to thank you for your time. It has been a joy to talk to you, and
Same, Jim.
your creative brain is working hard. It, and I'm serious, when you look at a table, you see something different than I do, which is kind of fun. And
Yeah.
that I like both of those products. I think they're way cool. The
Well,
rope,
thank you.
I think the rope is going to be fair to say huge because um, it has so many applications and the
Yeah.
slip knot idea. And, you know, our buddy Vince at E6LK, he has a habit of putting antennas in trees, laying on branches. And so
Yes.
he needs something like that.
Oh, for sure.
Yeah.
There's one thing too, is I'm gonna sort of pinpoint is that the with the cord itself, I've got really thin stuff. There's no reason why I can't do more conductor material to the center. And the more conductor materials, the less resistance and the more strength. So if I did a four chord version of this stuff, so it'd be about paracord size, it
Yeah.
would have a breaking strength of about 1,200 pounds. I
I
don't
wonder
think
how
there's
much,
any wire out there that can do that.
no, and I wonder how much power it can handle at that point.
Yeah, and the resistance would go down substantially as well because anything, remember I
Yep.
said there's like a little bit of resistance, but everything's in parallel. So it doesn't exponentially go down, but it goes down, it halves each time I add a
Portable,
double.
portable, quota perfect. It
Yeah.
really is. Great idea. Ben,
Well,
thanks a lot.
thank you.
It's been fun to talk to you. I've enjoyed it.
Same, same.
It's been a hoot.